Determinants for matrices. Oh, that's right. These are animated. My bad. There we go. Determinant. Is there one more? No. Okay. Determinant. It is a number that can come from any square matrix. Has lots of practical uses. We'll get into one of those. But once you go past that one use of determinants, you kind of go into the realm of more complicated than what we're going to get. Okay, but there are a lot of cool things you can do with a determinant outside of just the one thing that we're going to do. A number, it's a number. Okay, that's the weird part about determinants is that you're turning a matrix into a single number. Hi, Odell. Come on in. So you've taken square matrix and you turn it into a number, okay? Now, there's two different ways that these will be presented to you as far as, it'll say in directions take a determinant. But the one it'll say is DET, and here's a matrix, okay? The other one, it'll be two vertical lines around that matrix, and that also means to take the determinant. Note that these are not absolute value bars, okay? Not absolute value bars. And then the actual process of taking a 2 by 2 determinant and finding a 2 by 2 determinant is A times D minus B times C. You multiply these two, multiply those two, and then you subtract them. So, really quite simple when you go through and do it. So, any questions so far? Everybody good? So we got two here. So you say take the determinant. So you're going to go green times green. 9 times 5. I don't know why I did that backwards, but whatever. Minus red times red. Whoops. Negative 4 times 8. 9 times 5 is 45. Minus 8 times 4 is negative 32. And 45 plus 32, 77. And that's it. Okay, go down to your second one, same way. Negative 6 times 8 minus negative 7 times 10. Negative 48 minus negative 70. So negative 48 plus 70, which ends up being, what, 22? Next question is, what if I give you the matrix for x 6, 5, and I tell you that determinant equals 68. Thoughts, ideas?
We multiply by 4 times 5 and 6 by 8.
And then? That's all she's got. 4 times the 5 minus 6 times the x. I like that. Now what? You ain't got an equation yet, though. What's this got to equal? 68. There you go. Okay. Just use your determinant formula because you only have one missing value. All right. So use the determinant, make it 68, and then just solve it. So then 4 times 5 is 20 minus 6x equals 68. Subtract the 20, negative 6x equals 48. So x equals negative 8. You'll have to feel like that tonight. That's literally about as hard as they come as a 2 by 2. Okay? And remember, you can only do this with a square matrix. So the matrix has to be, as you would guess, a square, which means you have to have the same number of rows and columns. Okay? Now, we're going to do a 2 by 2 by hand. We're going to do a 2 by 3 by hand. Anything after that is off limits. Okay? Because a rule for 4 by 4, I don't even really know that well. Okay? So, and I'm not saying like I'm smart, but like I don't remember the 4 by 4 rules. Like I had to go Google them myself. Okay, so but we're going to do a 3 by 3. Okay, and that's what's next. Is this beautiful, majestic creature right here? All right. Now, logic would dictate if you pull the logic from the 2 by 2 onto the 3 by 3. Would be, you know, just do, okay, 4 times 2 times 9 minus 3 times 2 times negative 4. And that'd be it. That'd be great, wouldn't it? The same deal. The problem is you have numbers that you never use that way. You got to make sure you use all the numbers. So, this gets a little messy. Handwriting is key. Organization is key. That's why I like colors. Okay? Step 1. Here's what you do. You take the first 2 columns of said matrix and you rewrite them over here to the left. Or to the right, sorry. 4, negative 3, negative 4, negative 8, 2, 5. Okay. Take your first 2 columns, rewrite them to the right side of the matrix. Everybody good with that? Now, just like how we did with the 2 by 2, where we did A times B or A times D first and went down that way, you're going to do the same thing here. We're going to go 4, 2, 9. But then you also got to go negative 8, 6, negative 4. And 3, negative 3, 5. You don't have to do this color part, but that's what that entails. Okay. So you start at the top left, and you go down diagonally once, twice, 3 times. Okay? Multiply these all out. So 4 times 2 is 8. 8 times 9 is 72. Negative 8 and 6, let's see, 8 times 6 is 48. 48 and 4 is, hold on. 212. 192. That was close. Not really. Then 3, negative 3, and 5 should be negative 45, right? And then you add them all up and you get 219. Okay? And about that point, you are about 40, let's say 49% done. Not quite half. Okay, 49%. Ready? Now, go back to the top. You go from the top left, and you go down 3 times. Now, go to the top right. And you go down the other way 3 times. So 3, 2, negative 4, 4, 6, 5, -8, -3, 9. Multiply them all together. It's -24. What was that? 120. $216. Add those all up, you get 312. Is that right? Too red. Okay, that's another 49%. So 49 to 49 puts you where? 98. What do you think the last 2% is? Wrong. Subtract them. Just like the other one, right? Okay, so 219 minus 312. So what's that? -93. There's your last 2%. That's now we're done. Okay. -5, -1, 2. That's where your boo-boo was. U2s.
Yeah.
The top right here. This should be a positive sign, not negative. Okay. 9, 5, -4 is -1, 80. 4, -2, 6, -48. Add those all up, you get -218. Other side. 4, -1, 4 is 16. -5, 5, 6 is -150. 9, -2, and 2 is -36. Add those up, you get -170. -218 minus -170, -48. Now we're going to talk about one of them practical uses, and here it is. Yeah. The area of a triangle. Matrices can be used, the determinants of a matrix can be used to find the area of a triangle. All right, so the way this works is number one, your triangle has to be on a plane. Okay, and you have to have ordered pairs. If you don't have the ordered pairs, then it doesn't work. Okay, so -4, 3, 3, 1, -2, -2 is this triangle's ordered pair. The way this works is, if your ordered pairs are A, B, C, D, E, F, then what you do is you make your first column your column of X's, your second column your column of Y's, your third column you make 1's. Okay? X's, Y's, 1's. Why 1's? I don't know. Well, because if it was 0, it'd be a bunch of zeros, and that wouldn't do anything. So I guess 1 makes it work. I don't know. Whoever came up with this figured that out. Then you take that determinant, and then you multiply that by 1/2. Why 1/2? Say it all. Half this. Yeah, basically half the square. Base times height divided by 2. Remember that from your geometry days? Okay, base times height divided by 2. 1/2 base height. That's why there's a half in here. So, everybody good up there? Okay. So, to find the area of a triangle, what you do is you're given your 3 coordinates. 0, 0, 4, 12, -2, 8. Okay. You find that determinant. You set up that matrix. So, your x's are 0, 4, -2. Your y's are 0, 12, 8. And your z, or your last column, is 1, 1, 1. And you take that determinant. All right. So same deal. You rewrite your last columns, 0, or your first 2 columns, 0, 4, -2, 0, 12, 8. Now this one is going to end up being very easy because you have the origin in there. That's a lifesaver. That's a game changer right there. Because guess what 2 of your multiplications are going to be both times? 0. All right, which makes it really nice. So this one's going to go a little faster than the rest. Okay, 0 times 12 times 1. 0 times 1 times -2. 0. All right, cool. 1 times 4 times 8. That's 32. Okay, so there's our one ways. Let's go the other way now. 1 times 12 times negative 2. Negative 24. 0 times 8 times 1, 0. 0 times 4 times 1, 0. So 32 minus negative 24 becomes 56. All right, so that 56, that's the determinant of that matrix. But what do we still have to do? Times it by 1/2. All right, so 1/2 of 56, which ends up equaling what? 28. That's your area of the triangle. Okay? Makes sense. Now, real quick, you guys just watch. You don't have to write this one down. Since this is so easy, it's so nice, I'm going to do it twice. Except this time, I'm going to change the game. Oh boy, I'm changing order of the order pairs. Look at me, I'm crazy. And then let's go 4. All right. Yes, I know. I'm the weird one that likes to do math twice. Okay. So my left ones are going to give me end up with negative 24. And then my right ones, that's a 0. That should be a 32. And that last one should be 0. So 24 minus 32. Which ends up being what? Negative 56. Okay, so, and then we take half of that, right? Which ends up being what? Negative 28. Okay, now, notice how I changed the order of the ordered pairs themselves and how it changed my signs and my answers. One's positive, one's negative, but same numbers. See that? What's the title of the slide? Area of a triangle. What's area? Or area is always what? Positive. Area is always positive. So, and it doesn't matter, and the reason I'm doing this is because there are the zeros. I'm going to do it if there was a full-blown one. That's why I put it here. If you change the order of the ordered pairs themselves, it does not affect your answer long-term. Short-term, it does. Negative 24 first, minus 32, negative 56 here. But what you can do, since you're conceptualizing, since you're using a determinant for something, if this ends up being negative down here, you're trying to find the area, just turn it positive. Okay? Because we can all take these ordered pairs, put them in different combinations. Some will give us positive answers, some will give us negative answers, but at the end of the day, they're all going to be either positive or negative 28. So since you are using this as an application, you get to just take the positive one, since you are finding area, and area is positive. Okay, so don't freak out if you're looking somewhere and like they tell you a positive and you got a negative. You're okay. As long as your number's good, you're good. Just take the positive since you're talking about area. The end.